Hey guys, real quick before we start the show, I know this is kind of non-standard to have announcements before the show even starts. Sometimes there's advertisements here, but thought I'd throw it in here just because. First off, if you're going to the Open Source Hardware Summit, we are having a meetup. It's still in the works as of Tuesday night, which is kind of pushing it, but it will be Thursday night, 7:30 p.m. at a Boston location. Keep your eyes on the amphour.com and Twitter feed in order to find out where that is. We'll also be doing a tour at Bolt, the hardware accelerator, at 5 p.m. The other thing is Michael, who we're about to hear from here, has a Kickstarter. If you're listening to this and you're thinking, oh, I'm going to do, listen to little bits at a time, his Kickstarter ends in a few hours from the publishing date of this, the morning of September 4th in Eastern Time Zone. So if you're interested, skip ahead, read some of the links, and check out his Kickstarter so you don't miss it. If not, you can probably purchase it once the Kickstarter's over, but it'll be a little while. That's all. Enjoy the show. This is the Amp Hour Podcast, recorded September 2nd, 2013. Episode 161, with guest Michael Osman, gifted Grimgribber Grokker.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
And I'm Michael Osman of Great Scott Gadgets.
Great Scott!
What a brilliant name.
It is a great name.
Trademarked, I see.
How'd
Yeah.
you do that one? Was that?
Well, I don't know. I just claimed it as a trademark. I did a search to make sure nobody was using Great Scott for anything, or at least Great Scott Gadgets.
Well,
for
yeah,
anything.
I don't think you'd be able to get Great Scott, maybe.
No, it's too common a phrase.
Yep.
Right.
All right.
That's a good one, though.
I'm jealous.
Dave's going to have to pun it up later. He'll be thinking of other ones.
Because I'm a huge fan of Back to the Future, as a lot of people know.
Oh, yeah. Of course. That's what I always have to remind people of if they ask me about it. Like people who are native English speak the name. It's like Great Scott Gadgets. That's a cool name. And then when I talk to somebody who's a speaker, they always say, "Who's Scott?" Because they don't know the expression like we do. Even if they speak excellent English, they'll say, "Who's Scott?" and then I have to remind them. Well, you remember Doc and Back to the Future, how he says "Great Scott," and they say, "Oh, right, okay." They still don't get it. Yeah.
Somebody actually went through and added up the number of times he said Great Scott in the entire series. I think it was like 38 times or something.
Is that all?
I know, there was this webpage, some nerd went through and counted them all, as you do.
Well, through your 50th time through, I mean, what else do you have to do, really?
Well, yeah, exactly. Speaking of which, I'm probably going to build up my Lego Back to the Future after this. I'm going to shoot a time-lapse video of me building my Lego.
Very nice, Dave. Perhaps we should ask Michael about his, his background and stuff, too, right?
Yeah, let's get...
I don't know. I want to hear more about the Lego Back to the Future
I kind of do, too. But all right, we're changing the show format. All Lego all the time. So, Michael, tell us your background, though. I mean, where do you come from? What have you worked on in the past?
So I'm one of these people who came to electronics by way of software.
Duh. It's one of them, Dave.
Yeah,
I know.
No, that's good.
They're everywhere.
They're my new favorite. That's my new favorite type of person too for contextual electronics. So
it's like it isn't like when zombies attack. It's when software people attack.
It is.
What kind of software though? Are we talking like JavaScript? Or are we talking like C++?
Oh, all kinds of stuff. I mean, if you asked me when I was 8 or 9 years old what I wanted to be when I grew up, I probably would have said an electrical engineer or an inventor. And then I just totally lost sight of that for many years. And I used to put together electronics kits when I was a kid, but I never got very far. I could tell you how a resistor worked, but I couldn't tell you how a transistor worked. So, then I didn't pick up a soldering iron for 20 years or more.
Ouch.
Because I was, I just got interested in other things, music and computers, and and eventually got into IT stuff, and kind of worked for a long time as a system administrator and network administrator, and did a lot of little software development projects along the way, and gradually did more and more security work. Eventually became an information security consultant, and through my work in information security, I got into wireless communication security, and through that, I ended up doing just some kind of pure research in wireless communication security that led me to software-defined radio, because software-defined radio is kind of the ultimate tool for hacking on all things wireless. And then from there, I got into electronics to kind of try to build my own devices for wireless security research and development. So really, I mean, that was just in the last few years. 4 years ago, I had never done any surface mount soldering. I'd never programmed a microcontroller. I'd never designed any kind of a circuit board. It's all new to me.
You're making us look bad here,
Yeah, exactly.
Crap. That's awesome. I mean, that's really cool. So when you say like security, like wireless security type stuff, is that actual like people tapping into lines and trying to like see when other people are tapping in? Is that the idea? Because as much as
partly, yeah. Interception, eavesdropping on communications or interfering with communications, inserting your own messages and like spoofing legitimate communication, all of those kinds of things. And a lot of people are familiar to some extent with Wi-Fi security and how bad Wi-Fi security used to be, and how much better, how much it has improved over the years. But there are a lot of wireless communication systems in the world, and none of them have gone through as much positive change for security as 802.11 has. So there's a huge, it's an amazingly diverse field of different wireless communication systems and the security elements that they have or that they lack. And it's a fun field to be in, because sometimes you find things that are very sophisticated, and sometimes you find things that are just completely broken and wide open, and easy to break. So you get a little you get a little of both. Yeah. You get some stuff that's fun and easy to break, and then you get some stuff that's a real challenge.
I'm using, I think, WEP2, is it?
Probably WPA2.
WPA2, yeah, WPA2.
Which is
that? Should I be concerned?
Well, it's a huge upgrade over WEP, which was the
right.
the mechanism for securing Wi-Fi in the early days, and was completely broken.
Yeah, like the why even bother kind of.
Right. So I'm generally okay, but the NSA can still tap in.
Well,
that's its own.
Once it gets onto the wires, they probably can. Yeah. But today, I think probably the worst vulnerability for 802.11 systems, if you're using WPA2, probably the worst vulnerability is that there are some weaknesses in the way that a lot of Wi-Fi equipment sets up an initial key for you. So if you use like the built-in feature for it to generate a seemingly strong passphrase, right, it may not be as strong as it appears.
Right.
But as long as you set up WPA2 and you choose your own passphrase and you make it a good one, then it's pretty solid.
Right. Is there anything better than that, or do you have to like buy a commercial, like some sort of commercial, high-end commercial product to get better security than
So
WPA2?
most of the high-end commercial products actually have far worse security than WPA2.
Oh, right.
And I think it's mostly a function of the lack of peer review on a lot of the commercial products, the more proprietary products, that is. The open standards and the more popular open standards, and especially Wi-Fi, get a lot more scrutiny.
So it has the one thing that makes me sound sort of what I know, like I'm talking about in software, security by obscurity. I really don't know what I'm talking about, but that's the only thing I...
Yeah, security by obscurity is the norm in the wireless business.
Oh, okay.
Does it matter, though? Like, if somebody hacks your Wi-Fi, they're just going to steal your bandwidth. It's not like they're going to steal your credit card info and all that sort of stuff, right? What's the...
Well, they could steal your credit card info.
Okay.
And they could, as somebody who's on your Wi-Fi is very likely able to, gain access to every computer on your network and maintain that access even after they're not in range of your Wi-Fi.
Oh, fancy.
Right. Of course, they can install some backdoor thing, right? That allows them to access your machine from anywhere.
Yep.
But really, you need someone with intent to do that. Most intrusions are probably going to come from people who just want to suck your Wi-Fi bandwidth for an hour or something, right?
Most, yeah, but it only takes one.
Yeah, exactly.
and you're owned forever.
Yeah.
But once your computer's hooked onto the internet, you're screwed anyway, right? So Wi-Fi is probably the least of your problems, right?
How much of your past experience was actually like? Were you like securing other systems, or were you mostly just doing a lot of analysis and trying to break stuff for people?
Some of both. Actually, the area where I did the most work initially in my career in information security was in healthcare. And I did a lot of security assessments for different healthcare organizations around the U.S. This was in the early days of HIPAA. And
HIPAA?
HIPAA is a regulation of a rather significant piece of legislation in the United States that governs a whole bunch of aspects of how healthcare providers and insurers do a lot of different things, and the part of it that's relevant to security is that HIPAA kind of increased the potential for sharing of patient information between different healthcare entities, and so as a part of that, to kind of cover people's fears about patient privacy, they said, well, we're making it easier for them to share information about people, so we're also going to establish these rules about when it's appropriate for them to share information and how they need to protect information. So HIPAA included a privacy rule and a security rule that introduced a whole bunch of red tape for healthcare organizations, and it kind of forced them to start developing information security programs to protect the patient information that they had. So I was doing a lot of consulting for hospitals and other healthcare providers in the early days of the HIPAA security rule enforcement, and kind of helping them figure out where their weak spots were and figure out how to shore up their networks and their procedures. And eventually I found my way into a position as an information security officer for a hospital system. And from there, just kind of fell into a role as a wireless communication security researcher for the Department of Commerce.
That seems like a big jump.
There you go.
It was a big jump. I think I was very interested in Wi-Fi security, and I had published an article or two, not any real fundamental research of my own, but just kind of raising awareness of Wi-Fi security matters. And somebody just kind of called me up out of the blue and said, "Hey, we have this research lab in Boulder, and we have a whole bunch of people who are like RF engineers studying communication systems, and we want to look at security of communication systems, and none of our engineers know anything about security. So we just wanted kind of a information security generalist who knew something about wireless." And so I started there, and it was an amazing environment. I mean, because I was suddenly doing just pure research, which I love, and I was surrounded by all these amazing smart people. They were all electronics engineers and RF experts, and I was like the one security guy, the one Linux guy.
Oh yeah.
The one, maybe not the only software guy, but you know, my software skills were a lot more advanced than most of the engineers.
So you were the one-eyed man in the land of the blind, huh?
Yeah, exactly. And so it was a real symbiotic relationship for a long time, where people would come to me with interesting problems that I knew how to solve, and I was surrounded by all these other people who could help me solve problems that I'd never kind of tried to tackle before. Mm-hmm. So it became very easy for me to, that's one of the reasons that I was able to kind of learn electronics very rapidly, because I had, you know, half a dozen PhDs just up and down my hallway that I could chat with at any time.
That's awesome.
And
it's like boot camp
there
almost.
Were a lot of, there were a lot of conversations, a lot of circuit diagrams on whiteboards and you know, napkins over lunch. It was great.
Wow.
Cool. So they had seen your articles, they'd seen your publications and just called you out of the blue.
Right. Yeah.
That's another example of, we keep saying this all the time, that, you know, publish stuff.
Oh, absolutely.
Either on your own, you know, it used to be back in the old days, you published it in the journals, but these days it can just be on your own website or blog.
Right.
Or whatever, YouTube.
Yeah, right. I mean, I didn't have anything.
And then people will eventually come to you. If you've got the skills, people will find you.
Absolutely. I didn't have anything other than just some stuff on the web.
There you go.
Well, that's awesome.
Works every time, I'm telling you, folks.
So how did you actually start diving down into the hardware side then? Once, you know, you had these great mentors and guys to bounce ideas off of, what would you start diving down with?
Well, it was kind of two things. I mean, one was that I was surrounded by these people at work, but the other was that I was getting more active in the information security community and going to more conferences and meeting people who were involved in hardware hacking, and just kind of getting inspired that way. And ultimately, I started doing some work. I was investigating a number of different communication systems, especially public safety radio systems, at work. But I was having so much fun with software-defined radio doing that kind of stuff that I started picking up projects on the side. And one significant one was that I just sort of became obsessed with Bluetooth. And Bluetooth monitoring in particular, because there just weren't any tools available for Bluetooth monitoring. So I started looking into using software-defined radio for Bluetooth monitoring, and I found this recent paper that had been written on the subject, and I said, hey, this kind of is a good start for what I wanted to do, but I had some ideas that went a little further. So I ended up contacting Dominic Spill, who was one of the authors of that paper and who had published some code from that project. And I started taking his code and updating it and adding some new features to try to implement more complete Bluetooth monitoring capabilities using software-defined radio. And we started collaborating, and within a matter of a few months, we had a presentation at a conference together, which was the first time I met him in person. And
well, me and Dave still haven't met yet, so
yeah,
exactly.
Yeah, really, that's pretty funny.
Yeah.
Small
problem of
14,000 miles.
20,000 kilometers.
Right. Yeah. I think when I first started trying to contact Dominic, he didn't answer my emails for a while because he was driving from London to Mongolia. And then finally he was back in London and we started collaborating. And so that project ended up, we ended up implementing some really cool stuff and kind of showing people, hey, it's possible to discover Bluetooth devices that are non-discoverable, for example. Everybody thinks if you turn your Bluetooth device into non-discoverable mode that other people can't monitor its transmissions or find it, but we showed that that's absolutely not true, and we showed how to use the tool of software-defined radio to just monitor arbitrary Bluetooth packets over the air and actually derive enough information just by monitoring one channel to figure out what the frequency hopping scheme is, or the actual hopping sequence, and be able to follow along with it and all that kind of stuff. But ultimately, nobody really took our work, and very few people actually kind of reproduced what we did. One of the reasons, I think, is that the platform we were using was fairly expensive, and we were like, hey, buy this $2,000 piece of equipment and then take a soldering iron to it so that our hack works, and then you can do this stuff. And not many people want to do that. So I started the Ubertooth project in response to that, as a way to we had this relatively conceptually simple way to monitor Bluetooth on communications on one channel. And I thought, well, it can't be that hard to take a more traditional, lower cost approach as opposed to the software-defined radio approach. It can't be that hard to make a device that just monitors one channel and like spits out the bits over a USB interface to a computer. And that one project, the Ubertooth project, just that is what really motivated me to dive into electronics head first and try to build this thing. And it was a ridiculously complicated project for somebody who, like I barely knew what Ohm's law was. I wasn't going to say anything, but I had the benefit of being surrounded by all these engineers. I had the benefit of getting to know hardware hackers at these security conferences. I was inspired by like electronic badges made by people like Joe Grand and Travis Goodspeed and Amanda Wozniak and a whole bunch of people in the information security community who kind of encouraged me. And I also had the benefit, we're really in this golden age for people who want to get into electronics. Like I started out looking at SparkFun and going through the SparkFun, I think it's called the Beginning Embedded Electronics tutorials. So like I knew I was going to have some kind of a microcontroller. So I just looked for, how do I get started with microcontroller? And I found this tutorial, and I bought an @tiny and put it on a breadboard and got it to blink an LED, and that's such a huge
and it's all downhill from there, guys.
But it was amazing that I had this resource available to me online to walk me through that stuff, and I was able to just kind of ramp up and take on. I knew that I wanted to build a Bluetooth sniffer, but I knew that I wouldn't be able to do it right out of the gate. So I just sort of set out to find projects that would help me learn along the way. And somehow it all worked.
Sounds like that your research background kind of helps there too, because researchers are always starting from scratch with that kind of stuff. Like it's always, well, we don't know what we're doing yet, but we'll figure it out eventually. Because that's the whole point, right? You're going into discoverable territory, so
absolutely,
it's nice to have markers along the way from SparkFun and everybody else.
Yeah, and being able to do both software-defined radio and doing hardware were just very empowering to me, because like I came from a software background, and I would look at, but I had a pretty good knowledge of communication protocols, like internet communication protocols, and kind of how to look at a protocol and kind of guess at where the weaknesses might be and figure out what to probe. And so I would look at a specification for a wireless communication system, and I would flip through, the hundreds of pages, and it's very boring work to analyze these things, but I would go through them and I would point at something on, page 157 and say, hey, this message that's transmitted, this should be authenticated, and it's not. And that's a vulnerability. And people would look at me and they would say, okay, that's great, kid. No one's ever going to do that. And surely it's too difficult for anyone. Like the off-the-shelf radios don't actually support doing the kind of attack that you're proposing, and it's just not practical. And being able to build my own radios, either with software or hardware, gave me the ability to actually take theoretical vulnerabilities and turn them into practical vulnerabilities and demonstrate them to people and say, like, here's what happens when I send this unauthenticated control message and your radio dies, you know.
It sounds like this, if someone would have cut into this story like 2 minutes ago, they would have been debating between someone getting into technology and someone becoming a supervillain. And they dared me not to do it, but I did it anyways, you know, that kind of thing. I'll show you all. So, jury's still out on you, Michael, I gotta say. We'll see. We'll see by the end of the episode if you're a supervillain or not.
I'm a big believer in using superpowers for good.
Okay, well,
Awesome.
you can say that.
So
but
how long in the end did it take you to develop the Ubertooth 1? Is it?
Yeah, Ubertooth 1. Well, I started out with Ubertooth 0. And,
Right.
And I think, you know, that stage took me maybe a year and a half. But it really, like, I didn't know what it was going to look like at first. At first, I thought it was going to be, actually, I was thinking it would be a software-defined radio kind of architecture, because that's
Right.
what my background was. I knew basically how SDR equipment should work, and I thought, well, maybe if I could kind of rip the guts out of some kind of 2.4 gigahertz device, like the RF front end out of that, and then rip the back end out of something else, like a TV tuner, for example, and kind of make a Frankenstein device. It could be low cost and easy to assemble, and it would allow people to do this basic Bluetooth monitoring. And over time, it sort of became apparent that I was going to be better off kind of designing the circuit from the ground up, which was terrifying. But you know, I found these other projects to get me started along the way, and I just kept going with them. And I had great mentors, like the folks at the Boulder Labs, and Jared Boone, who of ShareBrain Technologies. He's an open source hardware developer that I met at a hacker camp, and you know, we're continuing to do a lot of projects together, but I had just a lot of people to help me along the way, and eventually I made Ubertooth 0, which was just a USB microcontroller and an RF chip, you know, a wireless transceiver IC, and an antenna, basically. And I designed it in Eagle and had a few made, and it worked. So then I started trying to make Ubertooth 1 at that point, because everybody was saying, like, all my friends in the hacker community were saying, hey, that's great, when can I buy one? And, and I was like, really? I don't know about that. But I just decided to try my hand at making something a little more marketable. So I designed Ubertooth 1, which was a little bit smaller, a little bit cleaner design, had a front end amplifier chip on it, so it had, you know, better RF performance than Ubertooth 0, but otherwise was basically functionally equivalent to Ubertooth 0, and threw it up on Kickstarter to see what would happen. And sure enough people wanted it that it actually, you know, it was, not only was it worth manufacturing, but it within a couple months of delivering my units to Kickstarter backers, I had enough additional sales, post Kickstarter sales, that I was able to quit my day job.
Fantastic. And it doesn't take a huge amount. I mean, we're into, you raised $50,000, $53,000 of your $16,000 goal, but it's only 441 backers.
Right.
And you know, in today's global economy and global marketplace, like, that's not
right.
many.
It isn't.
You know, 400, and it doesn't take many to get, you know, to turn it into a full-time business.
I mean, I announced the availability, or launched the Kickstarter at a conference where I was talking about the project. and I already had somewhat of a reputation within the security community, which is the primary people who would be interested in this thing. So even though I was new to building electronics, I have this niche market that was kind of ready for this and knew me.
Yeah, that helps.
It helps a lot, I think. Yeah. And thus Great Scott Gadgets was born.
And you've been doing that full time?
Ever since. And actually, Great Scott Gadgets was born like a year or two before then, because it was I just created a fake company website to...
as you do, yep.
Yeah, as you do. I was just, trying to get some data sheets out of manufacturers and stuff. And so that's, I don't know, I needed a fake company name, and Great Scott Gadgets was the first thing I thought of. So then later on, people were wanting to buy stuff from me, and I'm like, well, yeah, I have this company. And I'll just pretend it was legit all along.
Fake it till you make it, man. Works every time.
Yeah, absolutely.
So how many Ubertooth ones did you end up selling?
I still sell them today. I think I've sold a total of around 5,000.
Oh, wow.
Wow.
Over the last two and a half years.
That's awesome.
Jeez, that's a lot.
Where are you manufacturing it? Like, how'd you get launched into that?
Yeah, so I had, I just asked a friend of mine, like, hey, you've had some conference badges, electronic conference badges made. Who do you have manufacture those? And I got a referral, and I just tried these guys out. Ethernet, they're owned by somebody who lives in the Bay Area, but their operations are in Shanghai, and I had great experiences with them. Like my first ever manufacturing went very smoothly, or as smoothly as you could possibly imagine. Of course, there were minor hiccups, but I think I just kind of I kind of lucked out with a good referral early on.
Yeah,
and I've had such good luck that I keep using that manufacturer.
That's great. If you find one that's good, that is the right thing to do. And referrals are the right way to go in the first place anyways, I think, because you basically have other people do the hard work for
Definitely.
you of getting through the crap and and just finding the good ones, which is smart.
Right.
Yeah. I mean, one time I had a rapid project, like I was making a badge for a conference, and it was like a ridiculous thing that I put together in like 8 weeks, including design and manufacturing. And so it was, I tested 2 or 3 units before it hit the factory, and they were coming off the line in the factory, and like good 30 or 40% of them weren't working. And,
oh no.
And so they stopped the line, and like, I think I was in Europe at the time, and they're in China, and my main contact is in California. So like, it's just time zone nightmare. And it turned out, like, by the time I actually got on the phone with people, they had figured out that my load caps on the crystal were suboptimal, and they had fixed the problem and resumed production
on their own,
and fixed on their own. And
they made their money that day.
Which is good and bad.
So,
sometimes it's good that they found the problem and fixed it for you, but other times it's bad in that no, that you don't
give me
want
a call
them
next
to make
time
changes
too.
Like it's like,
right, exactly.
Yeah,
exactly. Well, they were trying to get a hold of me, but under the circumstances, it was great, because it was a very quick turn project, and there really wasn't time to do anything but that. So it was definitely, I was kind of sold at that point.
So it looks like you've done a couple badges here. I see the 2 TorCon badges on the Great Scott site. Are you like a conference junkie? Are you always at conferences? It seems like a lot of the... I don't really do many conferences, but I'm always curious about that kind of, like going around to a lot of them.
Yeah, I am. Especially lately. I think I stayed home for 4 or 5 months last winter, and then at this time of year, it's just ridiculous. I've been to 4 different places in the last month.
Oh wow!
And and I'm home like for a week between 2 trips to Europe right now. It's kind of ridiculous, but the information security community has a huge number of conferences, and they're just great people and really interesting content, and they're my primary market for most of the stuff that I'm doing. And I really I continue to do projects just, not related directly to my products that are, worth talking about at these kinds of events. Or sometimes they are directly related to my products. And I teach a lot of classes. I do a software-defined radio class that I teach, this year I think I'm teaching it 4 times. That's a 2-day class that I usually do at a conference. And so it's a big part of my life, both professionally and for fun. It's where all my friends are.
We don't have conferences here in Australia, be in the backwater and all.
There is actually at least one information security conference in Melbourne.
Oh, there you go. Have you been to it?
I haven't been yet. I
right,
have not been yet. But I hope to eventually.
I think we've lost Chris.
Oh no, I'm back. I'm sorry.
Oh,
I'm back.
No, he's back. He's back.
There he is.
I'm back. Yeah, sorry. Mute problems.
Someone's hacked in as we're.
Yeah.
Yep.
My Wi-Fi's been
talking.
hacked. So, you mentioned your 2-day course there. So that kind of brings us to the main event here, which is the Hack RF, which is the new Kickstarter project, which funds today or funds tomorrow. It's what is the trigger date?
38 hours left.
Yeah, I think. Right. So by the time you post this episode, there will be very little time left.
Like 10 hours left or so.
So if you're listening, if you're listening and you happen to be listening really soon after this episode was posted, then I'd love it if you go check out HackRF on Kickstarter and tell all your friends about it. But if not, then sorry for the bad timing, but it will be available in some form after Kickstarter.
Okay, that's great.
And by the time our next episode comes out, you'll have $500,000 in the bank.
Yeah.
Well, hopefully. We'll see.
That's what it's currently up to. It's up to $529,000.
Oh, great. We'll see how long it takes to for my bank to release the funds.
Yeah. Well, don't worry. You don't have to build anything until then,
there might be an issue or two there. Yeah.
You got how much?
Yeah.
And see, once again, it sounds like a lot of money, right? But it's only 1,700 backers.
Right.
Like I got like 2,300 backers for my little PCB ruler, right?
Yep.
It's 1,700 is not a huge number.
Well, it is.
But of course, the product itself is what, $275. So you multiply that by.
Exactly.
But it's really a percentage of the market that I think that matters there. It's the, how many people that want this kind of thing that are actually buying it. And I think that is a big chunk because, the SDR is not necessarily new, but it's in terms of like accessibility to the public, there's definitely a lot of interest in it. And I think this is a great entry product into that kind of thing.
Yeah, and that was one of the major motivations of the HackerF project in the first place, was to provide a very general purpose platform at a lower cost that people could use to get started with software-defined radio. I really, I don't see HackRF being the best tool for any one job, but it's a great tool that can be used for a huge variety of jobs, and I hope that it introduces more people to software-defined radio and kind of broadens the exposure of technology.
I had a whole bunch of people ask me about this HackRF thing on Twitter and other places, and they said, "Are you going to get one? Are you, And I think Chris and I talked about it last week, didn't we, Chris? And
we did.
Went, well, yeah, it looks cool, but then both of us went, You know, it's so well. Here in Australia, it's going to be like $300 for me, and it's like $300. Oh, I'm probably, I'm probably never going to really use it.
Right.
Like it'd be a fun toy. I'd love to be able to experiment with this sort of stuff, but it's just another. For someone like me, it's just another, gadget to play around with. Really, with the other 24 gadget boards I've got sitting in a box, so.
Yeah, and it depends a lot on what your potential applications are.
Yeah, and it was really the software that scared me off. I mean, like software, I always talk about software scares me off, but unless there's I'm not really into the software side of things, and that seems like what this is really good for. It's basically allowing someone you say to someone, programming, and now you can turn programming into RF signals, which is amazing, right? I mean, like before you have to go through tons of other stuff to get there, and now this is basically an abstraction layer for RF, which is that's the beauty of SDR.
Yep,
it's unreal.
It is, and that's what got me excited about SDR in the first place. Mm-hmm. I was a software guy, and I was in an environment where I really needed, in order to demonstrate the kinds of things that I was theorizing, I needed to build radios, and I said, hey, software-defined radios. Let's me build radios with software.
It's got my expertise in the title.
Yeah, exactly.
And so I was so excited about that. But then a few years later, I found myself turning into a hardware guy anyway. But I think part of that was just the immaturity of the field at that time. There were software-defined radio platforms several years ago, but they were more expensive, and the software was less mature. And so now we have less expensive, more accessible platforms, and we have better software frameworks. And I think the dream can be more of a reality now that if you're a software person, you can build radios with software-defined radio without having to learn all that much about hardware and RF.
Mm-hmm.
At what point is the software at the moment for something like this? Is it good enough so that you don't really need to program anything? Can you do useful stuff without having to cut code?
You can do some things without code, like spectrum analysis and demodulation of common things like FM radio stations.
FM radio, yeah.
Like land mobile radios, like public safety radios, both digital and audio.
Yeah.
Scanner type of applications, modes that are common for in the amateur radio community are well supported by some of the software that you can use with an SDR peripheral without having to write code. But I always encourage people to get into the software side of things. Like GNU Radio is the framework that I recommend people use. Everything that I do is open source. So I do only open source hardware and open source software. And I've been using GNU Radio for years. It's a fabulously powerful software framework for building stuff with software-defined radio. And it's pretty easy to get started with because you can write code for GNU Radio in either C++ or Python, so it doesn't matter if
I don't know either.
Either
so,
one.
Yeah, there's the first problem.
Even better than that, for getting started, is that it includes a tool called GNU Radio Companion, which is a GUI tool for building software.
Yeah.
Just kind of drag and drop, put your blocks, signal processing blocks together, and drag a line directing like the output of one into the input of another.
That's my style.
Yeah, it works.
Yeah.
It's an incredibly useful tool for just getting started, learning software-defined radio, learning GNU Radio, and even if you are a Python or C++ programmer, this is the way I recommend that you start with GNU Radio, because GNU Radio Companion actually, after you have built a flow graph in the GUI, you click a button and it generates Python for you. So
Right.
you can look at the code that it generates and learn how to emulate that and use those signal processing blocks in the same way.
Yeah, twiddle and
I think
hack
you've just
and-
scared off both of us by
No, that's
with
great.
the term software framework. No, but then you just won us over with that. Just click here and it generates the code. Yeah, thank you very much.
That's a great way to dive down into it too. I mean,
Maybe I should buy one now.
there you go, Dave. He's selling now too.
Yeah.
Right?
You should buy a HackRF. Or, if you don't feel like you're ready to jump in head first and spend the money on HackRF or any of the more expensive SDR platforms, you could get one of these Realtek TV tuner dongles that are...
Everyone's talking about those. Are they any good?
They're amazing. They're
For $20 they are. That's for sure.
They're more for $20.
Yeah,
They're
right.
amazing,
Yeah.
right? They're more limited in capabilities than HackRF, obviously, but as a way to get started and just experimenting with software-defined radio, it's so cool that people can do that for $20.
Yeah.
And you can use the same software tools.
You can.
use this.
Yeah, I've got that in my computer, and it's I think it's SDR Sharp or something like that. It's written a C# kind of interface program, and it's super simple. And the only problem with me is that I'm in a basement. That's the main thing.
There's a solution for that.
I know.
Once
Run a bit of coax out the window.
Yeah,
exactly.
Well,
you
yeah,
wouldn't,
I'm
you wouldn't want to
lazy.
actually get out of the basement. But
I know exactly.
yeah.
Can't let the air in.
SDR Sharp is one of the programs that supports HackRF today. And I think everything today that supports HackRF also supports the Realtek dongles. And they're receive only, whereas HackRF can also transmit. And they have a more limited operating frequency range. But it's still a pretty impressive operating frequency range. And you can explore a lot of spectrum and just get familiar with how software-defined radio works for a very low cost.
This would be an ideal platform for those people who want to quite possibly experiment with their car roll-in remote controls and things like that. If you've heard about, some illegal hacking of, cars, you can sit there and you can record people's remote controls and then open their car.
Definitely, and people have already experimented with those remote keyless entry systems with HackRF, for example. And all of those systems, I think, are vulnerable to some kind of attack. Like if you take somebody's remote out of range of the receiver and push the button and record the signal that it plays, if you beat the owner of that device back to their receiver, back to their car, or back to their garage door, or whatever, you can replay that code and use it once. Even if it is a rolling code with a non-repeating code.
Oh, right. You can still use it once.
Right, yeah.
And that's really all you need. Usually just once.
Yeah, like on a garage door, for example. Most of those garage door openers are extremely easy to program with an additional remote. So if you get into a garage door once, and you bring your own remote along, you can just push a button on the thing and program it to honor the codes from your remote, and then you can get in forever. Attacks like that are maybe not as well known as they should be. And of course, then there are some systems that don't even use rolling codes. Like anytime, the very old garage door openers, for example.
Like mine, yep.
Yeah. Some of a lot of the ones today that are multi-user. So if you have like an apartment complex or a gated community that has a gate that opens for 100 different remotes, that's probably a fixed code that all the different remotes are programmed to, because implementing rolling codes with a large number of remotes is not very practical. So those are things where you can just record a signal and play it back as many times as you want. It's fun stuff.
What about actually some of the hardware on this thing? I'm looking at the schematic for so it's called the Jawbreaker, right? I keep calling it HackRF, but that's kind of the more platform side of it, right?
Well, HackRF is It's a brand name. Jawbreaker is just the code name of the beta board.
Oh, okay.
Right.
Okay.
So what are the primary differences between the beta board and the finished HackRF, which you'll actually deliver?
Right. So I don't have a name actually. The finished HackRF.
Contest?
It probably needs some. It needs something.
It
Maybe
needs a Back to the Future name. It needs something
that would be good.
related to Back to the Future.
Maybe,
Yep.
yeah. So I'm open to suggestions. But for now, I'm just calling it HackRF. But by the time I ship it, I probably need to have some better name for it. But it will differ from Jawbreaker a little bit, but not a whole lot. Jawbreaker has a built-in PCB antenna, which was kind of stupid. And I just wanted something that people could use out of the box, where they could. All they need is a USB cable. They can plug it in and start experimenting with something. Because I was distributing beta boards to primarily people in the information security community who didn't necessarily have a background in RF and probably don't have antennas around. So I that was just a way to facilitate testing. So I'm going to remove that PCB antenna. I'm going to kind of shrink down the whole board by just removing a little bit of dead space and some things that were like pads that I had for development that didn't end up getting used. And so it'll probably be about 2/3 the size of Jawbreaker, and then I'll put it in a full enclosure and call it done. So it's not the important bits of the circuit design aren't really going to change.
Got it. What sort of enclosure are you going to use?
I don't know yet. I want it to be a full enclosure.
All steel.
All steel?
Yeah, something that'll not be great for RF, right?
Right. Yeah, I'm not sure yet what the enclosure is going to be. I was kind of putting off that decision until I knew what my manufacturing volume would be. I know I want it to be fully enclosed so I can throw it in my backpack and it won't get stuff, paper clips in the circuit.
Well, at your current volume of like what is it, 1,700 or something, that's not a huge volume. You wouldn't go injection molding a custom
maybe a soft
enclosure
mold,
for example. So
you might.
So
I don't know.
Yeah, maybe.
I already have one product with an injection molded case that I'm only manufacturing in quantities of 1,000 at a time.
Yeah, it's only 1,700 at the
so it's
beginning,
not out of
too.
the
It's not
question.
1,700 forever.
Well, it's China, right? We're talking about China. Yeah.
Right.
Although I would, if I was involved I would lay out the board to fit maybe an existing off-the-shelf case that then you can machine holes in, or something like that. So then you can order it directly from the manufacturer.
Beige cases.
All the mounting holes are in place, and you sort of
Yeah, that's definitely
I like
an
to
option.
play it safe like that. I just like being able to buy the case off the shelf and then just go, okay, I can drill the holes manually, but
Right.
in volume production, they'll drill them for me, and
I'm a big fan.
all that sort of
I'm a
jazz.
big fan of the sick of beige cases too. And
Right,
So,
okay,
I regardless of what kind of enclosure I have for the final product, it will support. It will support a sick of beige style enclosure. So if people are building their own HackRF board, for example, they'll be able to. Even if I have like a custom machined or injection molded case, they'll be able to have some kind of enclosure that they can get made affordably.
I kind of liked this sick of beige fad when it first came out, but now it's like I want to start something else. Sick of clear acrylic plastic with no sides,
Right.
campaign. I think it's been heavily overused.
Beige for president.
Yeah, I could see the point of view. I think that it's a great option to be able to support, though, for people specifically for people who are building their own boards, just because it's so easy to get those things manufactured, laser cut.
Of course.
A friend of mine had I don't know 36 of them or something like that, just made on his friend's laser cutter.
Yeah.
And we handed them out to everybody who wanted one at DEF CON, and it's really great to be able to have that very accessible
of course.
small unit manufacturing.
Brilliant. Should we get on to our questions?
Yeah, I was just going to say the questions are probably a good idea. I had a question, actually, add on to one of the questions that was in here. And of course, I have to find it now. Oh, yeah, so that's what I was asking
ask
about.
yours first, because
Yeah,
you
I was
get
asking,
priority.
that's why I was asking about the hardware. So the person here asked about the Zinc chip, which we've talked about. It's been popping up more, and it just if you had any opinions on that. And I was just wondering, just your design decisions behind the LPC. So it's an LPC as your main processor, right? And then you have was a Xilinx part I saw on there. I didn't know.
Yeah, it's just a CPLD.
Oh, CPLD, okay.
Right,
Yeah.
and what is the CPLD doing?
It is simply interface glue between the analog to digital converters and digital analog converters and the microcontroller.
Oh, so it's just right. So it's not any heavy duty.
No,
heavy duty parallel.
It is not
processing.
It is not doing any
just
digital signal processing.
glue logic.
Yep. And in fact, it may be possible to remove the CPLD from the next design.
Yeah, if you get like
I was gonna say,
Certus
we
or something
might.
like that.
Well, there's a pretty cool feature on this LPC 4300 microcontroller that we're using, where it's called SGPIO, Serial GPIO Peripheral, and it's basically a highly configurable external interface that can support various parallel or serial modes, and we're using it in a parallel mode with external clocking.
Right.
And so that's a pretty rare kind of interface to have on a microcontroller, something that can be a parallel interface that can handle 8 bits at 20 million times per second, actually 40 million times per second, with external clocking. And the only reason we put the CPLD in originally was because the ADC DAC chip, it uses a DDR interface, and interfacing the DDR with the SGPIO peripheral looked tricky, so we put the CPLD in because we knew we could do it that way.
Yeah, it's configurable, so you can always fix it later.
Yeah, it looks like we could do it without, but we might keep it anyway, just because it's kind of fun to have that configurability there.
And you don't want to go rocking the boat for your current platform works, right? So you wouldn't want to go changing it for this hack RF.
Yeah, I mean it's not as critical or as difficult to test as maybe changes in the RF path, but it's still.
Of course,
it's still.
It's a risk. You don't want to go there.
I don't want to delay manufacturing because I made some stupid design change that I didn't need to, and it didn't work.
Yep. Just because you thought it would be cool to get rid of one part,
Right. I think relating to your question, really question was about like Zinc
Yep.
processor. So we're not using anything like that on HackRF, which is a little unusual that we don't have any kind of FPGA on board. We just have this tiny CPLD that doesn't really have any digital signal processing capability. And then we have the LPC 4300 microcontroller. And it was our intent. This decision was made primarily by me and Jared Boone, who I mentioned earlier, who's really had a huge role in this project. We decided that we wanted to have kind of the lowest cost solution that would let us get samples in and out of high-speed USB at the maximum rate.
Okay.
And we didn't really care if we had digital signal processing capability on board, because the DSP capability in everybody's laptop is so impressive these days. And now there are some benefits to having DSP on board, so we're having fun with the fact that we did end up with a solution that have some capability, but that wasn't the main goal there. The Cortex M4 is or the PC 4300 is a Cortex M4, which is kind of the top of the line Cortex M series with DSP instructions, and it has a floating point unit, and it's running at 200 megahertz, and it has a Cortex M0 coprocessor. So it's it's not a very microcontroller. And it has this built-in high-speed USB interface that we've been able to run at very, very much at the maximum theoretical speed. So it's been great. And we haven't really missed having an FPGA on board. Jared put together this really cool thing, the HackRF PortaPack, which is it's just a prototype at this point, but it's like an add-on board that plugs into the Jawbreaker, and it has a color LCD screen and a couple of directional buttons and an audio codec with like headphone and microphone jacks. And he just wrote some code that does wideband spectrum analysis and plugs in a USB battery pack, and is just running the HackRF with this PortaPack in standalone mode, just as a handheld spectrum analyzer across 6 gigahertz of bandwidth. Well, not 6 gigahertz at once, like 20 megahertz at once. Right.
Megahertz window,
and he was able to get that running at, I think, 1,000 FFTs per second. So, which was nice. I mean, I'm not usually running that. Yeah. I'm not usually running FFTs that fast on my host computer. So I was pretty excited that he was able to do that, and it really kind of showcases the fact that we do have some DSP capability on this board, even though it wasn't our original intent.
Any plans to have that as an official add-on kind of thing for it?
It's definitely something that we're going to keep working on. Jared is he may be working on manufacturing a small number of them just for the people who have the Jawbreakers, right. and then he's definitely going to update the design for the final HackRF board, and we'll make it available for anybody who has a HackRF down the road.
Awesome. I got a question from Ojaz1. Will there be a different way to power the board? He can't imagine it being able to transmit any significant distance sourcing power from just the USB port.
That is a good observation. We don't really want people transmitting any considerable distance from just...
is that your problem, though?
The FCC is a thing, huh?
The FCC is a thing. And so, we're really pushing the limits of USB 2.0 bus power.
Yeah.
And this was another one of our kind of major design goals for HackRF. I mean, our big goals were, number one, open source hardware. Number two, very wide operating frequency range. Number three, transmit and receive. And number four, portability and being able to just plug this thing in on USB, and all you need is a laptop and a USB cable and an antenna, and you can take it with you anywhere you go. This was a really a key goal for me, and part of that is that it doesn't give us that much leftover power for, say, a front end amplifier for transmit. Right. We do have 10 dB or so of amplification that you can switch on at the front end, but that doesn't get you into any kind of power that's going to go further than tens of meters, most likely, for most applications. Right. So it's something that you can use HackRF to experiment on your bench or across the room. But if you want to actually transmit signals any great distance, you're going to have to add external amplification. And if you do that, you should also add external filtering, and you should know something about what you're doing and
get a ham license and everything else.
Exactly. So that's my answer for anybody who wants more transmit power, is you're on your own, but there are a lot of options out there. We have a 50 ohm antenna port, and you can plug whatever you want into the front of it. I just caution you to take care and be a good neighbor on the spectrum and follow your country's laws, and and all that.
Boo, hiss.
That's well, that's kind of like what Greg did. So Greg Charvat, one of the former guests, I went with him down to Hamvention. He ended up buying this old, like, super heavy, badass receiver, and then he ended up pairing it up with a transmitter separately because it was only a receiver. You know, like, actually, like, pairing up equipment like that, you could do the same thing here where you just have a transmitter, you hook it in, and then you're ready to go and using that as your front end, right?
Right. Yeah, that was a pretty cool hack.
Yeah, I like that stuff. I had a question kind of on a personal, selfish basis. Did I hear you're using KiCad for all your stuff now?
I am. Yeah, I adopted
How's that
going? Great. I adopted it for Ubertooth 1 originally. When I did Ubertooth 0 in Eagle, just because I was kind of going through the SparkFun tutorials, and that's what they were using,
Right.
and that's what everyone else seemed to be using. And then I started working on Ubertooth 1, and it quickly became apparent that I needed to make it a 4-layer circuit board. And my first thought was, well, let's see how much it costs to upgrade Eagle. And I said, well, it's not that expensive, but this is an open source project. I want anybody to be able to take this design and use it and modify it and do whatever they want with it. The open source is the most important goal for me and for my business. And so I decided I should look around and see if there were any alternatives, because I didn't want people to have to pay for a license for some software to modify my open source design. And so I found KiCad and I started working with it, and I thought it was great. It has its quirks, as do most tools. But I've gotten used to those quirks, and I think it's a pretty exciting project that's progressed a lot since I started using it. And I'm using it
even
now.
the last year or so.
Oh yeah, I'm using it now for absolutely everything, including some pretty complicated projects like HackRF and like my Daisho project, which is multi-person, multi-board thing, a project that involves FPGAs and USB 3.0 and all kinds of crazy stuff that's really kind of, we're pushing the limits. We're pushing KiCad to its limits in some ways.
What's it called? Daisho?
Daisho, yeah.
Is it
DAISHO? And this is a project that I started primarily for monitoring and security research into high-speed wired communication systems. So the idea is it's a main board that has an FPGA and some RAM and a USB 3.0 backend to a host computer. And then there are pluggable front-end boards that each implement some target communication medium. So we're targeting high-speed media like USB 3.0, gigabit Ethernet, HDMI, and we put on the front-end board connectors and transceivers like the PHY chips for the target technology, and we put a pair of each on. So a signal will come in, a connector into a transceiver, go over to the FPGA on the main board in digital form, and then go back out the other transceiver and connector. And it's a man-in-the-middle type of architecture that lets us do monitoring and injection or modification of traffic on the fly on these very high-speed wired communication systems. Yeah, so the project is pretty exciting, I think, because for multiple reasons. One is that we haven't had tools for some of these high-speed communication technologies. Like the only thing I can think of that is a similar architecture is Bunny's NETV.
Mm-hmm. Oh yeah, where you injected the messages on top of the HDMI signals, right?
Yeah, so we're doing a very similar architecture to that, except supporting higher rate signals. Like the NETV only supports up to, I think, if I remember correctly, 1080i HDMI. And so we're going to support 1080p and beyond. And we're also going to support a whole bunch of other different protocols. And we're throwing RAM on the board, which makes it more capable of doing fun stuff. And we're also putting on this back-end USB 3.0 interface, which is one of the most exciting parts of the project, because there are basically only two USB 3.0 chips that you can buy in small quantity today. And one of them is a pretty high cost microcontroller with USB 3.0 from Cypress. And the other is just a bare USB 3.0 transceiver from TI. And so we're just using the very simple transceiver and plugging it into the FPGA and developing an open source USB 3.0 core running on the FPGA.
Nice.
That's going to make a lot of companies angry, I bet.
Some maybe. I don't know.
Small ones happy, big ones mad, I think.
So, well, anybody who wants to develop a low cost or especially open source USB 3.0 device would probably find this quite cool. And we already have, this work is being done primarily by Marshall Hecht, who's a contractor working for me. And he's already completed all the USB 2.0 functions and is currently working on USB 3.0. And it's a little bit slow going, but he's made great progress and it's pretty exciting.
What's the plan for this? Another crowdfunded project?
I don't know. I suspect that Daisho may be less marketable than HackRF, but I'm not sure yet. This project still has a ways to go, and exactly what the applications are. Other than our main goal is just to get the platform working and support inline monitoring of a handful of different communication media. And that has some pretty good uses, especially in the information security community, which is my community primarily. And but I'm not quite sure how marketable it's going to be, because it will be a more expensive platform than most of the stuff I'm working on.
Well, the good thing about the crowdfunded platform is you put it out there, and if you don't meet the target, if there's not enough interest, well, nothing happens.
That's true. Yeah. That's true. And that's actually... That's one of my favorite things about doing the crowdfunding is just the fact that it is built-in market research.
Exactly.
It's great.
Did I see on your Kickstarter profile that you had one that was not successful? Was that right?
Yeah, I had one that was not funded, like a little over a year ago, and I actually think of that project as being a great Kickstarter success because I learned that it wasn't that device was not marketable the way I thought it was, and I learned that with very little cost. I didn't make 1,000 of them.
Can you
and then
tell us what the product was?
So it's called a Firefly Cap, and it's just a hobby electronics product, which is a little different for me to have something that's kind of pure hobby electronics. But it's a lid. Do you have mason jars in Australia? They're like a home canning jars or jelly jars that have a 2-part lid.
Yeah, it's like a seal.
Oh, right. The seal.
It has like a disc, and then there's a threaded ring that holds the disc onto the top of the glass jar. So these are super common in the U.S. Like everybody has some of these jars in their cupboard, and so what I did was I made a circular circuit board that's made to replace that disc, and it has contacts on it to which you can solder an array of LEDs, and it's a jar of fireflies, which of course lots of people in my hobby microcontroller world have built their own jars of fireflies, which is how this project started. But what was unique about this project was that I had it powered by a photovoltaic panel and a supercapacitor with an energy harvesting circuit that would work in indoor lighting conditions. And I mean, so you guys know that is a major challenge. Getting something like that,
sucking enough energy out of that and storing it.
Right.
Yeah.
So for me, as a designer and as my own personal project, that was the challenge, and that was what was fun about that project, was making it work indoors. And it under kind of moderate indoor lighting conditions, it would wake up as soon as it got dark after charging all day and put on a light show for a little while. It might only be 10 minutes, but it just sort of would, when it gets dark, it would simulate fireflies for a little while. And if it happened to get a lot of sunlight, like it was put in a window, then it would put on a show for much longer, like an hour or something like that. And so that was a big challenge, and that made the thing more expensive than it otherwise would have been. And so what I learned from putting it on Kickstarter primarily was when people see this thing, they immediately think of a $5 garden light. And they think, why does this thing cost $30? That's stupid.
Yep.
He's, I don't want to pay that much for this, and he's never going to reach his funding goal. And so it was extremely educational for me, and Kickstarter did for me exactly what I needed it to, which was show me that while this project was great fun for me personally, it wasn't marketable in the way that I thought it was.
Customers are still a thing, huh?
Yeah, go figure.
Just like the FCC, yeah.
Still a thing. So, but that was a really cool project, and it may be something that I revive someday, but it's never going to have the mass appeal than I thought it might. And I set my funding goal probably higher than I needed to, in part because I wasn't 100% convinced that that's where I wanted to take my company. That I wanted to make something higher volume for a larger market, as opposed to focusing on more niche products and focusing more on my own community, the information security community. And so it was kind of like, well, if there's enough interest to make it worth kind of taking on supporting all these first-time microcontroller hobbyists, then maybe I'll manufacture the thing. So I set the goal kind of artificially high, and that to some extent bit me too, because people would see that high number and say, he's never going to meet that goal. I won't bother.
Yeah, psychological stuff, right? There's always barriers.
Yeah. So
and that's a mistake a lot of people make. They think that, to be successful, they have to go into high volume consumer stuff. Yet some of the most successful people out there are the niche players.
Absolutely.
For example, it may not make you filthy rich, it may not make you Apple rich, but it's, but you can make a damn good living.
Absolutely.
I don't think the Pebble guys are filthy rich,
product.
Man. I think the Pebble guys are...
well, maybe. But, no, I wouldn't say they're filthy rich. Yeah, they got their $10 million or whatever, but... I'm sure you spent a lot of that actually.
Exactly. That's what I'm saying too.
Manufacturing a proper, polished consumer product.
Right. Yeah. That is such a huge responsibility.
Yeah.
Plus, it's nice that you target people that are really interested in, like people that are using SDR type stuff. At least have a very deep interest in it, right? You have a certain type of person you're targeting with that, so you probably get a lot of benefit from people that contribute to the repositories and feedback, bugs, and everything like that, instead of just asking for a lot of support, right? They'll go figure it out themselves.
Huge benefit, and that's been a part of the way I run Gray Scott Gadgets from day one, is that I do everything in the open source way, like all the things that people commonly do to execute and support open source software projects, I do with my open source hardware projects. I use open repositories, and I use wikis, and I have support channels like email lists and IRC channels, and I've really had the benefit of getting a lot of my own users kind of involved in the project and contributing to the projects. And now I have half a dozen contractors working for me, and they're pretty much all people who volunteered to help with my projects. And then down the road, I was able to say, hey, I have some funding for this
here's
thing.
Your money.
How would you like to, keep doing this kind of stuff and actually get paid for it. And that's my only recruiting method, really, is just taking volunteers who I know do good work and I know are interested in this stuff, and finding ways to give back to them the way that they're giving to my projects. I can't do that for everybody, but I try to do it where I can, and specifically in the form of contract work for them to do specific development tasks on various projects.
So I have another selfish question, because I was just learning GitHub this weekend, or Git really in general, and I'm not. So I mean, what's the deal with that in hardware? Because I'm kind of learning about that as I go, and I mean, does it fit well? Is there stuff that it's good at or not good at? We've been talking about it on the show a little bit in the past, and just revision control in general with hardware. Yeah,
I've pretty much migrated all my projects to GitHub. I like GitHub, and the main reason I like GitHub is because I really like Git. Git is an outstanding tool, and GitHub is a convenient place to use that tool. Almost all my projects have multiple facets. Like there's a hardware design, and there's some firmware, and then there's some software that runs on a host computer that talks to that firmware. And so I have multiple parts, some of which are software and some of which are hardware, and that all kind of need to be kind of consistent with each other and track version numbers together and so forth. So I have a lot of volunteers who are helping out with my projects, or contractors who are helping out with my projects. So it's essential to have some way to collaborate. I find Git to be an excellent tool for hardware and for software, as long as your design software for the hardware side uses a text-based file format, which KiCad does, of course. And we do we generally I get more collaboration on software than I do on hardware typically. Mm-hmm. But it's very common to have kind of in my loose-knit team, 2 or 3 people working on a hardware design together, where only one person is making substantial changes, and the others are acting as a sounding board, are doing design review, are helping with architecture decisions, or like, how about you use this chip here? And so we very much take the approach of one person is the designer, and other people are there to help that designer. The Git and other revision control systems aren't too well suited for software like KiCad, or really it's the other way around. KiCad isn't too well suited for software like Git.
Concurrent design, right?
Right, in terms of concurrent design, right, branching and merging. We've done a little bit of branching and merging with our KiCad designs, but it's dangerous waters.
Because I didn't put that part there. Who put this part here?
It mostly certain changes work really well. Like if you go through and update all of and put manufacturer and part number information in for all the 10K resistors in a design, without actually changing the layout, that kind of a change, it works extremely well in a revision control system. But actual changes to the layout or to the circuitry are things that we haven't done much of, other than just we haven't done much of in a multi-user mode, or multi-designer mode.
There's a script I saw over the weekend where this guy Robert on Twitter, he actually does he creates Gerbers from he dynamically generates them and then overlays them, so you can actually see where the parts have changed and everything. It's like a visual diff, which is really
in
cool.
Real time or close to it. Yeah, that's cool. Yeah. It's like a continuous integration sort of concept.
Yeah, it still seems really difficult, but it's just he wrote it for himself. So again, getting it to a wider audience would be tough. But yeah, it's really really cool.
Absolutely. I think that's a great a great use of the technology, and that's the kind of thing that I'd like to do more of, and I'd like to do more automated testing. When you're making hardware design changes, you can't really, you're limited as to how fast your testing cycle can be, but it's definitely worth pushing that limit. And it's also worth doing automated testing for things like firmware changes. But it's hard. You have to have some kind of a setup where you have the attached hardware and you have programming system and some kind of a automated tool to take whatever's been committed to the repo and like automatically compile it and install it and run some kind of test procedure. It's a lot harder when it comes to software and firmware than it is for hardware and firmware than it is for a pure software project. But that kind of continuous integration and testing has become the norm in many areas for software development, and it's an incredibly valuable tool, especially when you are trying to promote collaboration with multiple people. You want to find, if somebody breaks something, you want to find that out right away instead of finding it out like a month later after everybody else has forked that code. So finding ways to do that more with hardware and firmware is something that I'm very interested in pursuing down the road.
You software guys are messing up hardware in all kinds of good ways.
Well, we're only going to get so far with it.
Well, yeah, solder's still continuous.
A thing. Yeah, solder is still a thing, very much so.
Solder's my favorite programming language.
That's right. Yeah.
Yep.
It's gonna fix a lot of stuff still.
Do we have any last minute Reddit questions? There is a technical one here from Super Coo.
Super Coo.
How fast will the HackRF be able to retune and settle the oscillator to jump between frequencies?
Oh yeah, that's a good technical question.
Yeah.
So,
do you have a technical answer?
Yeah. I can say a few things about that. But one is that for a lot of frequency hopping systems, you don't actually have to retune in hardware because HackRF can operate simultaneously across 20 megahertz of contiguous bandwidth.
Yep. Right.
So if you have like in the 900 megahertz ISM band in the United States, there are a lot of proprietary frequency hopping systems that hop through a set of channels that all the channels together fit within 20 megahertz of bandwidth. So to implement that, you don't have to retune the hardware at all. You just retune in software, and it's instantaneous. But there are some applications certainly where you might want to retune in hardware, and Bluetooth comes to mind, for example, because Bluetooth operates over 79 megahertz of bandwidth, and we don't have that much on HackRF. So if you wanted to hop along with a Bluetooth network, you would have to retune in between packets. And in the case of Bluetooth, you have a little over 200 microseconds in between. That's like your minimum time between packets. And that's pretty typical. I haven't seen a lot of frequency hopping systems that really push that to a lower number than about 200 microseconds usually. With HackRF, we haven't really optimized the tuning and receive transmit time yet, but when we do, I expect to get that time under about 100 microseconds, just based on the parts we have. And we actually have multiple stages at which we could accomplish that tuning. So if it turns out that one stage isn't as fast as I think it's going to be, then we can always just use a different stage to do that tuning. So I'm pretty confident we'll be able to hit that 100 microsecond ballpark. However, and this is the big gotcha. That's the tuning time after the command is issued by the microcontroller. If you want to control frequency hopping from the host computer, you also add in USB latency.
Yep.
And
all the collisions and all the
going
crap,
to push you. Yeah, that's going to likely push you way over 100 microseconds, and potentially be a problem for any frequency hopping implementation. So if you want to do a frequency hopping implementation, and it is wider than 20 megahertz of total, all the channels, then you'll probably need to implement your frequency hopping in the microcontroller.
Yeah, right in the firmware there.
Which fortunately is pretty easy because it's an ARM microcontroller and it has a built-in bootloader. And if you have any experience in software development, it's a pretty accessible platform. If you've done any C code on any architecture, it's not too big a leap to learn how to write C for an ARM and get it compiled and installed. So that's one of the nice things about having kind of a general purpose microcontroller as opposed to an FPGA, is that it just makes that kind of development a little bit more accessible.
Did you have to learn FPGAs as well? Is that like another one of your skills now too?
Yeah, I'm not great with FPGAs. That's one of the skills that I've in particular sought out from people who work for me. But I know enough to be dangerous, and it's something that I'm working on getting better at. But I haven't had to do too much yet because we went with an FPGA list design for HackRF, and my first real project with an FPGA is Daisho, and I have other people doing those parts of the project. So I haven't been forced into becoming as much of an expert in FPGA development as I probably should be.
Well, once it's in the world, the buck stops with you, so you'll have to, you'll be learning it at about 1, 2 in the morning, day before it goes to the the manufacturing. So yeah. You'll be fine. It's easy.
Oh boy.
Well, Mike, I'm very impressed with that. 4 years, really. Like I said at the beginning of the show, you're making us all look bad here, but
yep.
It
honestly, a huge part of why I've been able to, do what I've done in a relatively short amount of time is online resources like the AMP Hour, like SparkFun's tutorials, like so many of the things that have been made available by guests that you've had on the show and all the people in the open source hardware community. And that is really why I am so dedicated to open source. Everything, even going back into my IT days, absolutely everything I can think of that I've ever done in my entire career that I was proud of, I did with something that was open source. And so I feel very strongly that I want to give back to that community, and that feeling has only increased as I've gotten into hardware because the rapid development of the open source hardware community over the last decade is really what has enabled me to take this stuff on.
Does that mean you're going to be there in Boston this coming week? Or are you going to?
Unfortunately, no.
Darn.
I just have a terrible travel schedule right now. For some reason, like everybody wants their conference to be in September and October, and
and so do weddings too. That's why I've missed it.
Yeah, right.
So I really wanted to go this year and last year, and both times had to make the hard choice not to.
Well, maybe next year. Maybe when Dave finally comes over.
Yeah,
right.
Finally.
I'll make you a deal. I'll make you a deal, Dave. If you go, I go.
Yeah. Right.
Oh man, that's easy out. I say instead we just start having conferences like in like January, February timeframe where there's a bunch of conferences in like Australia. So it's like, oh, sorry, dear, I have to fly to this warm location while you're here freezing in Cleveland. See you later.
That's the yep. Just move everything here. Not a problem.
Dave, just start a conference. That's what I'm trying to say.
Oh, right.
3-person conference. Me, you, and Michael.
I'm there.
Can do.
All right.
Can consider it done. Thank you very much, Michael Osman. Even your last name, I just realised, is OSSMANN. Open source software man.
Yes, I didn't even recognize that until somebody asked me. In all seriousness, somebody asked me just a few months ago, like if I changed my name to Osman for that reason. And I was like, oh wow, I never thought of that. Pretty funny.
Oh boy. next thing you know, we'll be having, people's kids named, you
Right.
know, Open or something. Or,
Right.
Yeah.
After famous astrophysicists or something.
Sagan's an awesome name. Thank you very much.
I agree, yeah.
I totally
get much
agree.
praise for that.
Yeah. So, Michael, where can people find you on the net? I mean, GitHub, sites, or where's the best place to start?
Yeah, probably the best place to start is greatscottgadgets.com.
Okay.
That has links to my blog and GitHub for various projects, and Twitter. I'm at Michael Osman on Twitter. But that means you have to know how to spell Osman.
Double S, double N.
Double S, double N. Yeah, that's good. All right, well, thanks again, man. And, enjoy your $500,000 that's about to hit your bank account.
Thanks.
Which I guess
Before
we
you
did like...
realize you have to produce them.
Yeah.
Right. Yeah, exactly. That's the thing is I see that number go up and I'm like, oh, wow, that's a big obligation.
That's a lot more units.
There's like 35 hours left, folks, as we're recording this.
Probably about 14.
Right.
No, by the
14
time
when
you
this
hear
hits
this,
press.
there's probably like 1 hour left. So
Yeah.
Right.
Yeah.
Well, thank you guys so much for having me. I've been listening to the show for, 100 episodes or so, and
We're sorry.
it's one of my favorites, and it's really a pleasure to be here.
Well,
Thank you very
thanks
much.
for coming on. All right, well, we'll see you at the next conference, hopefully. But until then, we'll be looking at all your awesome projects.
All right.
see you, mate.
See ya.
See you then.